Throughout its reign in the 1970s and 1980s, the Jt8d became the most widely produced engine of its class, with over 14,000 units delivered. Its dual-spool architecture and characteristic can annular combustion section, featuring 9 individual chambers, facilitate modular maintenance that significantly reduced aircraft ground time. With the arrival of the 200 series, the engine took a technological leap by incorporating a larger diameter fan and more advanced control systems, optimizing thrust up to 21,000 pounds and adapting to increasing noise regulations for the MD-1880 family. With over 670 million flight hours accumulated, its legacy of mechanical robustness and its ability to operate in extreme conditions keep it, even today, as a mandatory case study in the airworthiness management and the prevention of human error in aeronautical maintenance.
The Pratt and Whitney Jt8d is not merely an engine, but the cornerstone underpinned the golden age of single-aisle aircraft, paving the way commercial aviation after its introduction in 1964. Originally conceived for Boeing 727, this low bypass turbofan was an engineering masterpiece for its time, successfully adapting the core of the robust G-52 design enabled aircraft such as the Boeing 7200, 200, and the McDonnell Douglas DC-9 to operate successfully on short runways and at high altitude airports, opening up regional routes previously accessible to jet aircraft.
The Pratt & Whitney is a dual-spool low-bypass turbofan engine divided into 4 main sections that align sequentially to generate thrust. The intake and fan section, which sucks in air and divides it between the bypass flow and the core. The compression section is split into low pressure and high pressure compressors that drastically compress the air. The combustion section, featuring a can-annular design with 9 individual chambers, where compressed air mixes with fuel and ignites. And finally, the turbine and exhaust section, where high pressure and low pressure turbines extract energy from hot gases to drive the compressors and fan before expelling them at high velocity through the rear nozzle to generate thrust. Well, technically speaking, the Pratt & Whitney features a highly complex mechanical architecture based on a dual spool design which allows its rotating components to operate an independent yet coordinate optimal speed to maximize thermal efficiency and thrust. At the front, the structure begins with a robust intake section and a two-stage fan that performs the critical function of trapping in atmospheric air and dividing it between the bypass flow and the engine core. This primary air moves into the six-stage low-pressure compressors and subsequently into the seven-stage high-pressure compressors, where a series of stator and rotor blades drastically increase pressure and temperature before the ignition phase. The heart of the engine is distinguished by its iconic annular combustion section, composed of 9 individual chambers arranged in the ring and uniform heads, and distribution and greatly facilities maintenance and boroscope inspection. Following combustion, the high energy gases first strike the high pressure turbine, which extracts the necessary power to drive the high pressure compressor cycle, and then the low pressure turbine, typically consisting of three stages, which provides the torque and required to spin the front fan and the low pressure compressor. Finally, the structure is complemented by an accessory gearbox strategically located at the bottom to power vital systems such as lubrication and electrical generation or generators, concluding in an exhaust nozzle designed to mix the airflows and optimize the final propulsive force of the turbofan. Thank you.